All right. So thanks everyone for coming. My name is Dan Miller. I work for Unity Technologies. This is my first translated session, but I have some wonderful help in the back there, and hopefully it all goes well. If you guys have any questions related to what I'm talking about today, or kind of general Unity things, you can feel free to reach out to me via my email, or you can find me on Twitter at my handle there. So today I'm going to be talking about interactive 360 video, the support that Unity provides for video, as well as some new features in 2018.1 which allows you to capture 360 video inside the Unity editor. I'm going to be going through and describing how you can start to utilize these features and build up applications outside of just rendering a single kind of 3D video. So what is a 360 video? Well, at its core, it's basically an elongated video that then gets wrapped around a sphere, and you're able to view it from many different angles and kind of encompass you within. Inside Unity, we support 360 video with our new video player. This video player was introduced in Unity 5.6 and has added continual support for 360 options for things like rendering to a skybox, which I'll be showcasing in a demo, as well as support for 4K, 8K, and plus video sizes. And lastly, hardware acceleration on all platforms, so you can take advantage of built-in features on specific hardware. New in 2018, which launched this morning, if you guys didn't see that announcement, is what we're calling a 360 stereo capture in Unity. So stereo here means stereoscopic, which is for rendering different images to each eye. And this allows video to be viewed in what feels like a 3D environment. So in order to enable it inside of Unity, it's now a special checkbox in the XR settings panel. It's available for capturing through a couple different methods, which I'll showcase here shortly in a demo. One of them being an API, if you want to manipulate or capture the textures through code, as well as being able to take advantage of what we call our generic frame recorder. And there's a built-in kind of UI for that method. Currently, this is only supported in the editor and on the PC, so it does not work on Mac. Here's a small sample video, let's see if we can get it to play, that showcases what you might be able to see. All right, so it looks like that isn't loading, but you'll be able to see it shortly here in the demo. So I've mentioned that you can capture the 360 video, and now I want to talk a little bit about how it can be used. So 360 video is becoming more and more popular for social media platforms, as well as being able to view on things like YouTube. What you can do today with the stereo capture is you can create potentially an immersive trailer for your application. You could use it to render out a high fidelity 3D scene and then use that to run on lower end hardware. And you can also start to kind of layer and compose it inside of Unity, where you take the capture and then build up with additional 3D elements. A couple things to keep in mind when using the 3D capture is that currently The stereo separator, which acts as the interpupillary distance, or the distance between your eyes, has to be hard-coded. What this means is that you have to choose a specific value at which the two images are captured. Depending on what platform you're going to be viewing or playing this on, this could mean that you want to make sure that you look up the specific IPD for something like a Google Cardboard, or try to choose a variable middle for something like the Oculus Rift, which has an adjustable IPD. Another thing to keep in mind is that currently the MP4 codec only allows you to render out videos at 4K. There's an additional codec if you want to render them higher. And lastly, something to keep in mind is that the way the frame recorder works, at least from the GUI standpoint, is that it starts right at the beginning. So right at the start of play mode. So if you have maybe lighting effects or other things that take a little bit of time before they begin, you may have to edit your video afterwards. So now let's hop into the Unity editor and see how this works. So right now I have a very high fidelity scene that is taken from the 3D game kit. So this is a newly released project that's available for free on the Asset Store, and it details a kind of action game where you as a character walk around beating up monsters. You can see all the different elements as I kind of move through the scene, and really how dense this environment is. To render something like this in virtual reality isn't really possible in its current state because of the computational cost required. You can see we have some dynamic elements like moving moss or grass, as well as some kind of crystals that'll blink here as well. Now, in order to capture this in 3D, the first thing I've done is I have a small script here that takes a reference to my camera as well as different render textures. You can see in the script here that it's a fairly simple API if you want to begin to capture via code. We're simply capturing each eye to a specific render texture, and then we're converting it to an equirect map, which is similar to that original GIF that I showed of the map going into the globe, or vice versa. Another thing to note here is that you can see my stereo separator, or IPD, is hard-coded. When I'm running this script in the editor, you'll see that my render textures get populated from the eyes. So we can see a little example of what the render texture looks like down here. So here is for the left eye, and here's for the right eye. And here's how these combine into an equirect, where each eye is then stretched and placed over top of each other to render out a video. Now, that's how you can render out 360 video from the API. Now I'm going to be talking about how to do it from the GUI, which is much easier. In this project, I've included the generic frame recorder. This is a publicly available asset for free on the asset store from Unity. It's evolved a lot over time, and to make sure that you're up to date, it's also open source on GitHub if you're interested in getting it from there, again under the Unity Technologies GitHub repo. So the frame recorder was originally created for rendering out videos like Adam or Book of the Dead, which you may have seen last night. With 360 video becoming more and more popular, we've included a 360 option. In order to find it, you can simply go to Window, Recorder, Video. And now we have a simple GUI that we can configure in order to capture the 360 video. So you can see I've already selected the video category up here, where we also have options like animation clips, as well as rendering out PNG sequences. For my capture method, or collection method rather, this is where we can specify the 360 view, which allows us to capture those two eyes via the GUI. When I select that view, you'll see that there's a couple different options for which camera we're going to be capturing from, the output width and height, as well as the cube map width, and lastly, this stereo checkbox, which gives us those two videos, one per each eye. And again, the stereo separator, which allows us to hard code that IPD. Now, by default, we're going to be rendering to the MP4, and we have just a folder here where all of our recordings go that's just outside of the Unity project. For this file name, I'm going to name it to something a little more appropriate. And you can see we have options to add things like tags or specific values to the name. Now, you can see we also have things like custom frame rate if you're targeting a specific platform or a frame rate. And one thing I want to mention is that currently with 360 video, and just recording in general, is your application isn't going to be running at the actual frame rate of the application, because this capture does require some resources on your computer. So now that I've set this up, you can see I have a camera here in my scene that is going to be the area at which we're capturing from. And for now, I'm just going to leave it as a static camera, but it would be really easy to potentially kind of animate this camera if you wanted to do a fly-through, as well as position it at different angles to get different captures. So now that I've set this up, I can just hit the Start Recording button, which will initiate the scene to load and then start rendering out to this recordings folder. And you can see specifically, it counts the number of frames that we've recorded so far. Now for this one, I'm just going to stop it early, but obviously you could have this continue to run if you want a longer capture. So I've walked through how you could utilize the API to begin capturing, as well as how you can use the recorder GUI in order to configure and capture. And now I want to show the last method. For this last method, I'm going to use the timeline. Once you've imported the generic frame recorder into your project, you're then able to add a custom timeline track by right-clicking in the timeline window and clicking Recorder Track. Now, I'm able to specify exactly in a timeline when I want to start recording. What this means is that if I had a lot of different timelines or elements going on within my scene, I could specify an exact amount or time for when I want to start recording. And in order to do that, you simply right-click and add a recorder clip. If you're familiar with timeline, you know that it's really easy to stretch or squash the length or duration of any track within it. And very similarly to the recorder GUI window, when you click on the recorder clip, it has the same configurable settings that we can start to manipulate in order to render out to 360 video. You can see here we have the option to go to 360 with the same sort of manipulable variables or fields. All right, so now I've described all the ways that you can start to capture 360 video within Unity, and now I want to start to show how you can use that. So in this project here, this is just an empty Unity scene with a couple helper scripts on a couple different objects. One of them I want to point out now is what I'm calling the camera editor control. And what this allows me to do is rotate the camera based on my mouse movement, similarly to how I would be using my head within a 360 video. So to start off, I want to first just walk through a couple ways that you can render videos in Unity, and then I'll hop in and start using one of the stereo captures. So to start, we can render video to what I'm calling a flipped sphere. And this is just a simple sphere that I created and flipped the normals on, so that when I go inside of it, I can still see. In order to render video to this, I can simply select the mesh and add the video player component. From here, it's already configured to override the renderer and is simply looking for a video clip. To start out, I'm going to make sure that I put my camera kind of inside the sphere. And you'll notice some problems that we're running into right away. One being the fact that the video is extremely dark, and that's based on the fact that right now, with my sphere, I'm still using the standard shader, which has lighting information on it. In order to change that, I can simply create a new material. And once I've assigned this to the sphere, then I'll change the type of shader that it is in order to have it be unlit and instead just take a texture. Now when I play the video, you can see that things are much brighter and rendering a lot more naturally. Now, the strength within Unity and 360 video really comes when you start to mix in dynamic elements, use things like animations and particle effects. And in order to fully take advantage of that, this sphere rendering can be a little bit limited. And just to showcase that, I'm going to create a little cube. Now, when I locate the cube in my video, you can see it there. It has the ability to kind of clip through the video. And that's because the video is, again, just rendering to this sphere. The other feature that I mentioned at the beginning of this talk was the ability to render video to the skybox. And now I'm going to be walking through how that works. So for now, I'm going to simply disable these objects. And then I'm going to set up the video player to, instead of rendering to a mesh, to render to a render texture. So you can see that I've done that here with this video player. The render mode here was on the material override option for the sphere, and now it's on the render texture option. If you're not familiar, a render texture is just an empty texture that we then output video to in order to render it. You can see that I've selected my video clip here called Movie 8. And one thing to keep in mind is that I've already sized my video render texture, which we call video RT, to be the same size as the video clip. And to show that, you'll see that when I select the video RT, we have the size of 2048 by 4096. And when I go and locate that video, you'll see that we have a similar size. Now, in order to find out some stats about your video, you can obviously go through your operating system, but inside Unity, we also have this somewhat hidden button that allows you to view source info. And here's where we can find that size in pixels. So now that I'm rendering my video to a render texture, it can be applied to a material that takes in that render texture and is used as the skybox. So in order to configure that, I want to change the shader from standard to skybox panoramic. This is the special shader that we've built into Unity in order to render these 360 videos. You'll see here that the shader now has an input for a spherical texture, and that's what our render texture has become. Now, in order to get this to work and override the skybox in the scene, I can simply drag it into the empty scene and have it start to render there. Now, you might notice that things look a little bit off, and we kind of have this small world effect going on in the bottom, and then the same opposite effect happening at the top. The reason for that is that we haven't yet configured this shader to render a 3D video which has both video streams laying on top of each other. As we can see here, with the right and the left eye in a single video. In order to do that, all we need to do is configure this 3D layout to be either side by side or over and under. And we know that our video right now is over and under. So now when I play my scene, you'll see that the stereo video that I've captured is visible all around me. If I were to put a 3D or a virtual reality headset on, this video would feel very much 3D and very similar to if I was in this scene here, because we've captured each eye separately and then are playing it back through stereo. You'll notice there's some subtle movements, again, with the crystals and the grass. And you also might notice that the lighting does a little bit of a flicker there. That comes from the fact that I captured it from the beginning of the application, and potentially I would want to edit some of that video that I captured. Now that we've captured the video, this is where Unity really starts to shine, and you'll see how we can use this scene with this backdrop to start layering in elements. In order to do that, I've created a small scene that has a couple of the 3D models that I've gotten from the other project. So you can see those here now. And let's go and view them from here. You can see that by default, they have some nicer looking materials, and we can position the camera somewhere like this and make sure that our directional light can match what we're seeing in the video. So you can see the shadows kind of coming from a certain angle, and we can start to manipulate these objects to look like they really fit in the world here. Now when I hit play, you'll see that as a viewer, you can start to have these real 3D elements in the scene with the 3D stereo video kind of composed in the background of the elements. For this particular project, I have built it out to mobile virtual reality headsets, and because I'm only rendering a video and a few 3D elements here, it's well optimized and works well. Whoop. So the other thing we can do is we can start to take a few more elements from this project. In order to do that, I've grabbed a couple unique particle effects. One of them being a little butterfly. And similar to the 3D elements, we can really just start to place these anywhere around the scene and anywhere around the camera. We also have some fireflies, which we can locate over here. And you might be able to see them, especially when I hit the play button, but they are a little bit small. But it really starts to build up this ambiance, or this feeling that you're in a much more interactive and lush 3D environment, especially after you've captured the scene in 3D. I'm just going to add one more other effect here, which is just some fog. And you can see that a lot of these effects are fairly subtle, but really come to life when viewing this in 3D. So you can see some of the fireflies there, as well as the little creature, and then 3D elements specifically taken from the captured project. All right, so now I've showcased a little bit on how you can capture 3D scenes within Unity and how you can start to layer up 3D elements to create immersive experiences for lower end devices, as well as can be utilized with adding even more detail for higher end. One last thing I wanted to note is that while it's possible to render videos in stereo, it's also possible to just render videos in that equirect, which is just a single capture. The next thing I want to talk about is basically moving through some captures of either pictures or videos within Unity and how to easily set this up. The nice thing with Unity, as I've mentioned before, is the ability to take still images or video and layer in 3D content. When looking at something like mobile virtual reality, most headsets don't have the capability to do positional tracking, so the camera is always static in the scene. You can use this to start to place elements based on perspective, and you'll see this in a demo shortly. One last thing I wanted to note is that this demo that I'm building upon or showing next is heavily based on this interactive 360 sample project, which is also freely available on the Asset Store. All right, so now I'm going to load up another scene. So for this one, I'm doing a similar technique of rendering to the skybox, which, as I mentioned before, is the kind of outer limits of what we're seeing. For these pictures, I simply captured them outside in the lobby yesterday. And you can see that I've just kind of put a 360 camera on this little table. Now, what I'm doing here is I've set up little hotspots within the scene in order to trigger different elements. So you can see this hotspot here, and when I look over it, it now changes to a different video. You can also see that I'm on the different element here, and you can start to put in 3D elements based on where you are and where the camera is located. So this is using that perspective that I was talking about. You can also see me hanging out over there. So in order to accomplish this, what I'm doing is I'm taking the camera here and I'm simply rotating around my scene until I find the right perspective that I want. Once I've captured that, you can then start to position 3D elements in order to make them look like they're kind of sitting or standing on certain things. So you can see the camera here, and we have Unity Chan, who now looks like she's standing specifically on this desk. I could also kind of put her over here, or potentially on the stairs. Again, just using this idea that we know the user can't move within the space. So you can see here again, I'm just kind of looking around out here, We have another little hotspot over there. And once I look at it, it just triggers. And now you can see Unity-Chan looks like she's just standing right on the edge of the desk because we know where the camera itself is going to be. So I mentioned this was heavily based on the interactive 3D sample. And what I'm doing is I'm simply taking these little look hotspots, which have a little image right here, and then just swapping out a texture or video, you can see here, every time that I select one. So it'd be super easy to create another hotspot and start to kind of walk through the world here. Now, another thing to keep in mind is that similar to setting up the 3D elements, I also want to make sure that I get the correct perspective on some of these hotspots. So for this one here, I'm going to make sure that I kind of manipulate this element to be somewhere in the scene where I've captured another video. And the other thing that I'm doing with each of these hotspots is that I've created a little list of objects to activate. And what this allows you to do is easily turn on other objects as well as kind of hotspots in order to keep moving throughout the space. So for this one here, I can, instead of the booth 2, I can do the booth 1 picture. And for now, we'll just see if this one works. So it's kind of that far off one. Might be a little bit difficult to kind of locate. But again, I'm using kind of just the gaze gesture. So this is more configured for kind of mobile or lower end VR here. And it is a little bit tricky to line up perfectly. And I think that one was actually configured to be this single image here. So now we can go back to the purple booth. I can line it up like that. And again, we're just kind of moving throughout this space using a little bit of perspective and just swapping videos or pictures every time we move. All right. Whoop. So the last slides I wanted to show, it looks like I accidentally clicked out of them. We'll see if they're there. Nope. Is basically just talking a little bit about our support for spatialized audio. So currently in Unity, if you go to the audio settings, you can go Project Audio, we have the ability of a couple built-in audio spatializers. Whoop. The first one is GVR, which stands for Google VR. And this is the Resonance audio spatializer. Next is the Microsoft, and lastly, the Oculus spatializer. And once you select one of these spatializer plugins, you have the ability to then configure your audio sources a little bit differently with a spatialized checkbox, as well as some 3D settings. And I can just show that really simply here. If I create an audio source, at the bottom here, we now have this little spatialized checkbox. And once you do that, you also are going to want to go and adjust some of these settings, like the spatial blend, as well as potentially configuring these 3D sound settings to really get that specific sound that you want. So with that, it pretty much wraps up my presentation. Hopefully you've learned a little bit about how to capture 360 video inside of Unity, how you can start to begin to utilize that to build up more complex scenes, as well as how you can easily string together different pictures or videos to create a small walkthrough, and then start to add unique elements like 3D models or look targets. I think we have a little bit of time for questions, so thank you for coming. So I believe the questions were supposed to go towards an iPad, but you can also just yell one out if you want.
Can you recommend a 360 camera?
Yeah, so the question was, can you recommend a 360 camera? So this is the one that I have. It's called the Mi Sphere. I can show it to you a little bit afterwards, but what I really like about it is that it produces high quality pictures and videos, and there's an app on my cell phone that allows me to easily transfer them off of the camera itself and easily start to kind of import those into Unity or use them in different ways. Mm-hmm. Any other questions? All right, I'm not sure if there's questions going to that, but I am going to be around all day. If you guys have additional questions, you can find me around. All right, thanks a lot. Oh. Okay. This one? So there's a question about how to record sounds in the Unity scene. So in the recorder plugin, there is actually the ability to record sound as well as video. So there's a small checkbox with how you're recording the sound. I'm not sure if you can separate that functionality, as if you can only record sound and not record video. But after you record the video with sound, you could potentially take that through a different piece of software and just extract the sound. All right, thanks.